MDM4U 3.4 Cause and Effect. What we're going to be learning how to do is analyze the results of a correlational study. So usually the main reason for a correlational study is to find evidence of a cause and effect relationship between variables. However, a strong correlation does not prove that the changes in one variable cause changes in the other. Establishing a strong correlation between variables is the first step in determining whether one affects the other. So what we're going to do is discuss various types of relationships in a correlational study. This will give us some tools to better analyze the results of a correlational study. Starting off with a cause and effect relationship. This is referred to as a direct relationship. A change in X causes a change in Y. The relationship is clearly evident, and this example is a physical process which is very clearly evident. So, example, the height from which you drop an object increases its impact velocity. So we know that a falling object accelerates at 9.81 meters per second every second. So the higher that you drop it from, it's going to directly affect its impact velocity. So this is a cause and effect relationship between the two. So a common cause factor, or an indirect relationship, an external factor causes two variables to change in the same way. In this example, a town finds a strong correlation between parking fees at a beach and the local tomato harvest. So these are our two variables, parking fees at a beach, so total amount collected as well as the total harvest of tomatoes. And if we were to see both of these increasing in the same season, then we might think of these variables as one affecting the other. Is it parking fees causing larger yields in tomatoes, or is the larger yields in tomatoes causing more profits for parking fees? That being said, we need to also consider that it's possible that there's an external variable. Weather is a common cause factor that causes an increase in both variables. So with better weather, we're going to have more people wanting to park at the beach to enjoy the day, and also tomatoes are growing in better conditions. So they're both growing together, but they're not directly affecting one another. This is an indirect relationship or a common cause factor. Next, reverse cause and effect relationship. The dependent and independent variables are reversed in the process of establishing causality. So we are familiar with that phrase, Y depends on X, and sometimes it can be challenging to attribute the effect to a specific variable. Here's an example. A linear correlation is drawn between coffee consumption and anxiety levels. The researcher theorizes that drinking coffee causes nervousness, but instead finds that nervous people are more likely to drink coffee. So that being said, we are having trouble identifying or reversing the cause and effect relationship. So this takes some expert knowledge to know things about each variable. For example, drinking coffee, it increases your heart rate, and as a result will cause more stress on the body, and therefore if you establish it with the opposite direction, which is being nervous is causing you to drink coffee, that would be the reverse relationship between these two variables. It's the coffee that is causing the nervousness. Now, that being said, accidental relationship. A correlation exists without any causal relationship between variables. Example, females enrolled in engineering programs and reality TV shows both increased for several years. The positive correlation is likely to be entirely coincidental. So, it's possible that the two variables could just happen to be changing at the exact same time, and that there isn't necessarily that relationship between the two variables. A presumed relationship. A correlation does not seem to be accidental, even though no cause and effect relationship or common cause factor is apparent. So let's say that there was a correlational study and they found that the fitness level and number of adventure movies viewed was correlated. So it seems logical that a fit person prefers adventure movies, but there are many factors that affect the relationship, and identifying a direct or indirect cause would be difficult. So, some other things to consider. An extraneous variable. An external variable may affect either the dependent or independent variable. Subject-specific knowledge when designing a study or interpreting a correlation is helpful. So, that being said, subject-specific knowledge when designing a study or interpreting a correlation is helpful. So therefore, you might have information which will allow you to have deeper analysis of a specific topic. So just finding a mathematical relationship is not as powerful as being able to theorize all of the factors which are related to the different variables. So that being said, one technique that people use or scientists use to rule out any external factors is by using a control group. So this is a process of completing an experiment which can be used to help establish causality. A technique to establish a relationship between two variables involves sorting a population into two groups. These groups should be as similar as possible so that extraneous variables will have about the same effect on both groups. The researcher varied the independent variable for the experimental group, but not for the control group. So there's the control group, which no change occurs, and the experimental group in which some change has occurred. And that can be anything that the scientists are researching. Any differences in the dependent variables for the two groups can then be attributed to changes in the independent variable, whatever change was made to that experimental group. So researchers want to see if technology assists students in math class. The experimental group are randomly selected to use laptops to assist with their learning. The students in the control group are not given laptops. So if there was an improvement in some standardized tests such as EQAO, then the difference in the two groups, if there was one, would then be attributed to this change in that independent variable.